A motor unit is made up of a motor neuron that controls or innervates a group of muscle fibers following the all-or-none principle, that is that it controls either all of them at once or none of them at once. And the innervation ratio is how many muscle fibers this motor neuron controls, and larger muscles tend to have a higher innervation ratio. We know that a motor neuron controls or innervates a group of muscle fibers to form a motor unit, but we also have to have in mind the different types of muscle fiber and motor unit. So there's type 1 that involves the high endurance, low force and slow contraction. So this is appropriate for long distance running. Then there's the in between of the two extremes that involves quick contractions, yes, but a moderate force and endurance, and this is appropriate for the 400-meter run as an example. And then we have the extreme of high force but low endurance. So we know that in the 100-meter sprint we generate a lot of speed and power, but we cannot maintain this state for very long. The recruitment of these muscle fibers follows this principle, and it's that activating motor units from smallest to largest is the rule, and depending on the exercise. So in the 100-meter sprint, you will actually activate the type 1 motor units first, but then because of the demand of force, you will quickly change to type 2B/type 2X, same thing. Isometric contractions involve the muscle generating force without shortening or lengthening under tension. An example of this is when hanging on a bar. You will need force to prevent you from falling, but this does not mean that your muscles will necessarily change shape. Then we have the very common isotonic concentric contractions, where the muscle shortens under tension. So throwing a javelin would be an example, and so would a bicep curl. The opposite involves isotonic eccentric contractions, where the muscle lengthens under tension, and you will feel your biceps lengthening under tension when, for example, you put your hands up. Lastly, we have the least common type of motion, the isokinetic motion, where the muscle generates force at a constant speed, and an example of this would be leg rehabilitation machines. Skeletal muscles are the most common in the human body, and their function is essentially to generate force via the use of contractile proteins. This force is then used by tendons that help them move the bones. They involuntarily contract during cold conditions, as we saw before from the shivering, and they have a striated appearance. Then we have the cardiac muscles in the heart. An example of this would be the ventricles that cause the pump. They have a striated appearance as well, but this time they are in involuntary control. Lastly, we have smooth muscle, also in involuntary control, this time having a non-striated appearance. It is found in other organs, in their walls and blood vessels. It also controls the diameter of the lumen, so they have a role in vasoconstriction and vasodilation. And lastly, they can help move certain substances. We know that the bicep is the main muscle during a bicep curl, obviously, and therefore it is the agonist because it controls the movement the most and generates the most force. It generates a pulling movement that is contrary or opposite to the possible pushing movement that the tricep may make, and therefore it is an antagonist. We can also have a synergist that essentially helps the agonist perform the movement, but it does not have a main role. Lastly, we have a fixator. An example of this is the deltoid in the bicep curl that essentially prevents unwanted movement and helps the agonist perform the movement in a smooth manner. We also have the different abilities of muscle, the different changes in muscle size. These definitions, I think, are pretty straightforward, though we have looked at the different types of contraction before and the different roles of muscles during a movement. Let's just look at the antagonist again. So it opposes the agonist. We know that the tricep causes a pushing movement, which is contrary to the pulling movement of the bicep, and therefore we want the tricep to relax and lengthen during the movement, and this is done by a process called reciprocal inhibition. Lastly, we also have the different ends of muscle. So there's the insertion, where the bone is being pulled. We know that the bicep, in this case, pulls the radius up, and the muscle attachment to the fixed bone, also known as the origin. In this case, the scapula is the origin of the biceps, as it does not move during the bicep curl.